Okay, welcome once again. Let's continue with our discussion on the superposition. So, di ba? We have a second degree linear equation, differential linear equation, and then eventually we have a first solution and then a second solution. So, if we add these two solutions, we will have another solution, and which is also a solution for our differential equation in this form. Now to get this to determine the value of these two, we need to equation. That's why we applied or we try to get the value of y when time is equal to 0 and then the value of y dot of t when time is equal to 0. So y dot again is our velocity. So having get this this is our initial conditions. Then eventually, no, by simple mathematical operation, we will eventually get our final answer. We will have our C1 and our C2. So na po yung another concept gyapon ni superposition, no? If a solution of a homogeneous linear differential equation is multiplied by a constant, the resulting function is also a solution. So ang first na itong giniscuss ni superposition is if nakakaido ka solution, i-add mo, that will become a solution of the differential equation. Dili sad, ingon niya nga if nado kuno kay multiply na constant, no, di ba? So you try to multiply constant and then the resulting function will also become a solution. So, here we have the sum of two solutions. So mo siya, no, atong first is the sum of two solutions, and then here we also have the multiplication of the constant throughout the equation. So here, no, let's say we have our phi1 of t and phi2 of t. Let's say this is our independent solutions of the governing differential equation. So alam mo, kalibo ka lang symbol mo nga phi1, y1, u of t. So kaning phi1 of t mo siya tong y1 of t sa atong previous na example. So of course, kung imong kuha ni first derivative ni y1 of t, that will become y dot 1 of t, and then kung imo ba differentiate, you will have y double dot 1 of t. Same thing that will happen on this one. We will have y dot 2 sub 2 of t, and if you differentiate that, you will have y double dot 2 of t. So here we just use the phi, and then if you plot these values in our equation of motion, we will arrive this one, no, with these equations. So this is just the mass times this one, the damping coefficient, and then the lateral stiffness. Now let's say we have a constant, so we multiply a constant C1 sa ato ang phi1 of t. So similar gyapon siya nga concept earlier. So if you have a phi1 of t, then you apply the constant there. If you take its first derivative, you will still have C1, phi1 dot of t, and C1 times, if you still take another step to differentiate, you have the phi double dot 1 of t. So if you try to substitute that in this equation or to the equation of motion, ato ang nabuhat, or to the simple second order linear differential equation, no, it will become in this form. And since C1 is constant, not a C1 diri, C1 diri, and C1 diri, we can factor that out as shown in this equation, and then it will be left with this equation. So we have a C1 times this equation. So C1 times 0 is just equal to 0. So here, hence C1, phi1 of t is also a solution of the equation of motion of the equation 1. So, if you can see, no, if we notice na when we try to multiply the whole equation with a constant, it will still remain the same. No, it will arrive with the solution. Therefore, the multiplication of that constant or this, if you try to substitute this to our equation 1, no, instead na katong m double dot u dot t plus cu dot of t plus ku dot of t is equal to 0. If you try to substitute, no, instead of u of t, we will have our constant c1. So we still arrive at the solution, and then we still have another function. So this resulting function is also a solution. So mo lang gina siya yung basic concept ni superposition. If you add the two solutions, you have a solution. If you substitute a function with a constant, the resulting function like this one will also become a solution. So mo lang gina siya yung concept. So this one here na-apply ang concept no ni characteristic equations. We call that characteristic equations or the auxiliary equation. So if you remember sa inyo ang differential equation, kanino ba mo sa una nga, let's say, igdon mo to find the solution of y double prime plus 4y prime and then plus 4y is equal to 3. Then if you remember no nga, we convert the y double prime into r squared plus 4r rather, plus 4 is equal to 0. And then you will have r plus or minus etc. as your so this is if man dumduman ninyo sa inyo integral calculus, this is we call this our auxiliary or characteristic equation for this differential equation. So this is the auxiliary equation and the differential equation. So na dila ma-apply nato si superposition principle. So, tulong para mas masabla na to, let's have again our second order differential equation. AY double prime plus BY prime plus CY is 0. So, kung tanong ngayon, solution ani will be in the form y of t is equal to e to the rt. So, let's say atong constant na dito, instead of k, we have the r. So if we take its first derivative, we will have y prime of t is equal to r e to the rt. And then its second derivative, that will become r squared e to the rt. Now if we substitute this, no, since we naman tayo this specific solution, if we substitute these values to this differential equation, we will have a times r squared e to the rt plus b times r e to the rt plus c e to the rt is equal to 0. If you notice, we have a constant, the e to the rt, so we can factor that out. Then we will have e to the rt times ar squared plus br plus c is equal to 0. Eventually, we will have our ar squared plus br plus c is equal to 0. This becomes our auxiliary equation for this differential equation. So alam mo katarantahan na this is just a review no sa inyong previous years. So mo to nga tingala mo nganong hindi kan nga si y double prime imong r squared. It is because we know by superposition that if we try to multiply a constant or substitute a constant here, there, and then a function, we will have a resulting function which is also would lead us to the solution of our differential equation. So, dahil since we have a constant, sa to kanitong buhaton, if we have a constant to get the constants of the kuan katong ang sa atong superposition, we need to consider the initial conditions. So mo na gyud siya concept. If we have u of t and then we have this kuan katong the sum of two solutions as a general solution, since the constant C1 and C2 can have any value, the general solution can represent an infinite different solution. So kinahanglan tag initial conditions katong two unknowns, therefore we need two equations or two initial conditions. So atong buhaton is we take the value of that function. Sa previous example na to, y na to itong gigamit. Here we have u of 0 and the u of 0. So these are the initial displacement and then the initial response velocity for our single degree of freedom system. So we will have this. So same na gyud siya sa concept atong no, same na siya nga concept. We try so we have our initial conditions here. Cy prime o cy double prime. So eventually, so di ba, come up din ta by elimination, by the process of elimination, masolve na to si C1 and then si C2. So if na kay, so this is a known function, this is an equation. We have the response velocity 1, response velocity 2 at time is equal to 0. The initial displacement u0 and then the initial response velocity u dot 0. So ato man namin malaan and then masolve din nato si C1 and then si C2 or C sub 2 na constants. So let's apply that concept sa ato ang free vibration response, no? So mo niya equation 1 diba, that is the mass times the response acceleration plus the damping coefficient times the response velocity plus the lateral stiffness coefficient k times the lateral displacement of t is equal to 0. Since kabalo man ta nga ang property ni second order differential equation will eventually have a solution like this one. So alam mo kawala again, no? So sa previous example, ato lagi gigamit is y, no? And we have the y double prime plus cy prime plus ky is equal to 0. And then natay solution, di ba? Y of t is equal to c naught k. So here, that's why we have the u and then u of t. And then instead of y of t is equal to c naught e to the kt, here we just use u of t is equal to ge to the st. So nga naman nga wala to gigamit si c because naala tayo c diri, hindi na akong doble-doble. And nga nung walay k because kanina k is different than k. Here this is constant on this equation but it doesn't necessarily reflect the lateral stiffness coefficient k. So mula siya we have the u of t is equal to g e to the s of t. Kani si g and then the s is constant. Our t here, this is our time. So mo to siya, no? So if we apply this one, no, to this equation, so kung sa nato og u dot of t or the initial derivative that will become gs or sg sge to the s of t and then the double prime y or u double dot of t into s squared g e to the st. Now, let's say this is our equation 2. No? Now, let's substitute this to that equation 1. So, kung ato na sa substitute, we'll arrive in this equation. So, no, it looks familiar. Superposition principle and then we will have our auxiliary equation. So, if imong tan-awon, natay common g e to the s t. So we can factor that out. So we will arrive in this quadratic equation. So we have s squared plus c over m, s plus k over m. So ganun lang animal. So this one, no, if we multiply the whole equation with 1 over g es of d e to the est equals to 0, then we will be left with ms squared plus cs plus equal to 0. Then we just further multiply the whole equation with 1 over m or the mass. Then we have squared plus c over m s plus a over m is equal to 0. So we have here a quadratic equation. So ato gyapon ning magamit sa tong free vibration na motion sa tuang structure. So take note of this equation 4. Let's move forward. So let's have our case 1 for free vibration. That is an undamped vibration response. So when we say undamped, di ba natay mas we already have our auxiliary equation, di ba? So we have an auxiliary equation sa to equation of motion katong s squared plus t over m s plus k over m is equal to 0. So for a free vibration response nga undamped, pasabot there is no damping. So that our C coefficient here, damping over coefficient, that is equal to 0. Then we are left with s squared plus k over m is equal to 0. So here now we introduce another notation, omega, which is equal to square root k over m. So omega, this is the natural angular velocity of our structure in radians per seconds. So, if we try to substitute this notation on this equation, so we will have s squared plus omega squared is equal to 0. This is how for an undamped free vibration response. So, ganun omega squared because our omega is equal to square root of k over m. Para since ato among value diri, we have the k over m, so we just square this one to get the k over m. So our equation then is simplified to s squared plus omega squared is equal to 0. Now, if we try to take a solution, we will have s squared is equal to negative omega squared. Then we try to extract to the square root of the both sides, the left hand side and the right hand side. Then we will have s square root of s squared is equal to s is equal to, we have here a negative omega squared. So if you remember, no, we have, if we remove negative 1 and the omega squared, omega squared. So see omega squared, that will become s is equal to omega times square root of negative 1. And we know that the square root of negative 1, that is a complex number or imaginary number. So we will have s is equal to a positive or negative I omega. Mao siya. Ato ang equation 6. So na-solve na to, no, we have s. Since so natin solution diri, di ba we try to use the superposition principle of the auxiliary equation. So na-solve na to siya si, so we apply this function, no, on our second order differential equation. Then natin na-solve nga s for a undamped free vibration response. So take note, no, nga for a damped and undamped nga free vibration response, sila mo siya ang solution sa tuang s. For undamped free vibration response, we have here a positive and negative I omega. So if we substitute that, no, so since kabalo man ta nga u of t is equal to g to the st, and since naman day duha ka solution, no, sa tong s, we have the positive and the negative. Sa ato pa, we have G1 e to the S1 of t plus G2 e to the S2 of t. So atong S1 will be the positive I omega shown here, and our S2 will be the negative I omega as is shown there. So we have the general solution for our undamped free vibration. Ato ang displacement is will look like this, where G1 and G2 is the arbitrary constant. So here we have already our I and our omega. Now we have arbitrary constant G1 and si G2. So si G1 o si G2 is atuwagin po na siyang solbaron. So we already have this, no, this equation. So saan galing nato to siya pagsulbad? We have initial conditions, U of 0 and U dot of 0. Since this is our U of t, so atong U of 0 diya, when time is equal to 0, we have G1 e to the I omega, and our time will be equal to 0, so mo na siyang times 0, plus G2 e to the negative I omega times 0. So mo na siya. So eventually, you will have your initial condition, U of 0 is equal to G1 plus G2. How about the second condition, the U dot of 0? So our U dot of t is equal to, that will become I omega G1 t minus I omega G2 of e to the negative I omega t. So kanina no, ato lang siya differentiate U dot of t. And then we eventually have this general or the differentiation, and then we try to get the U dot of 0. So we need to get the U dot of 0, we will have this one, and eventually we have the solution that the U dot of 0 is equal to I omega G1 minus rather I omega G2. So ato lang ni pagkaw si I omega, no? So this equation, we will have U0 over I omega. So nag-multiply sa equation with 1 over I omega, which is equal to G1 minus G2. And then naman tayo isang U of 0 is equal to G1 plus G2. So dali na kayo. If we add these two equations, masolve na to si G1. This will be our G1. And then if we subtract the both equation, masolve na to si G2. And this will be our G2. So if ato na siya i-add sa ato ang katong equation na to ganiya earlier, this one, we add it here. So nanat na U of t di is equal to 1/2 times U of 0 plus U dot of 0 omega times e to the I omega t plus 1/2 U of 0 minus U dot of 0 over I omega times e to the negative I omega t. And then, so if imo na i-distribute si kaning exponential nga part here, we will have so for this part here, so we'll have that is 1/2 U of 0 as e to the I omega t plus 1 half. So, ito lagyan mong i-distribute si 1 half as an exponential times u dot of 0 I omega to the I w t. Now, on this other side, try to distribute it here. You have 1 half u of 0 e to the negative I omega t minus 1 half u dot of 0 over I omega times e to the negative I w of t. So we will have a very long equation pa do diri if we try to distribute this one. So let's settle lang sa ato ang substituted value or this one with our G1 and our G2. So let's have a quick review again of our basic mathematics, no? So inyo ang numericals. So we have a Taylor series expansion of e to the x. So if we expand it around x is equal to 0, we call this our Maclaurin series. So asa man nato ni we're gonna use this e to the x. So if you notice no natay ingani nga notation e to the I omega t or e to the negative I omega t. So we will apply this concept of Taylor series on this side. So we will have our e omega to the omega I omega t. And then we can expand this one around x is equal to 0 on this function. But eventually, there is a pattern on that resulting expansion. No? By Taylor series, we have common Taylor series. We have this common exponential Taylor series. But since this is expand at x is equal to 0, we call this a Maclaurin series. And that there is a very common Taylor series. So this one here on this side, this is a Taylor series of cosine t. And then this side here is the Taylor series of sine omega t. So sa ato pa, since the e to the I omega t is equal to this function, we can rewrite it as e to the I omega t is equal to cosine omega t plus, don't forget the I here, I sine omega t. So this equation here, it will look like this. We call this the Euler's equation. So actually, ang Euler's equation, no, that is e to the x from the Maclaurin series. That is equal to cosine x plus I sine x. So we just applied that concept sa ato para mas dali na to siya ma-solve. So applying the Euler's equation, so positive ug negative man to siya, di ba? We have positive and negative I omega t. Same rin pa ng result na. So applying the Euler's equation sa to ang previous example. So balik na no. We already have, where is that? This one, di ba? Siya taas tayo. We just rewrite that one here. So we have itong first one, we have, di ba, 1 half na to. U of 0 e to the I omega t. So we have 1 half u of 0 e to the I omega t plus 1 half u dot of 0 over omega e to the I omega t. And then ang atong another part niya, kung na G2 nga part, we have 1 half omega of 0 e to the negative I wt minus 1 half u dot of 0 over I omega e to the I omega t. So if we apply this concept no in this variable here also, we will arrive with this specific equation that our lateral displacement u of t will be equal to the initial displacement at time is equal to 0 times the cosine of the our natural uh, angular velocity omega t plus the initial derivative of the first derivative or the response velocity over omega sine omega t. So we'll arrive with this equation, no? If we try to simplify that one, so medyo taras na siya gamay. But if dali na siya i-simplify, then we'll arrive at this equation. It is easy to verify that this equation is the solution of the governing equation of motion by direct substitution. So for random free vibration, mao ni siya to ang equation of motion. And if we graph that one, we will have this motion. No? So on the x-axis, we have the time, and then on the y-axis, we have the displacement. So since this is an undamped free vibration, this is undamped free vibration. So wala siya damping, di ba? This is our first idealization. If you remember, ang first na to idealization of the building is we only have the mass M here, rigid roof, and then we have the flexible column, and then it will oscillate on both sides. So mano siya atong sample diri. The oscillation will continue forever. Since wala may damping, we will have this motion. So this is the free vibration response motion of an undamped SDF system. So this is unrealistic, but it is shown like this. So this is our equation of motion for a undamped free vibration response. So we have our amplitude here. The amplitude is that is from 0 and then 2 is highest at most peak of our cycle. So we have a cycle here. So this one, this is our amplitude draw. The amplitude draw is just equal to the square, that is just equal to the square root of the square of u0 plus the square of u dot 0 over omega. Then we will have our amplitude. And then we have here a notation of t. What is this t? T is our natural period. That is equal to 2 pi over the natural angular velocity. So, ano naman yung natural period? The total cycle of the system. So, the total cycle of the system, so, is measured from this point, let's say from this point, no, from point 1 until sa point, kung kano sa siya nibalik sa iyang original nga, naay ka ng neutral position, na na-complete niya ang whole nga cycle. So this is our period t is equal to 2 pi over omega. So as you can see here, now we have the fourth position. This is initial position at rest. And then we have a displacement at time 2 at position 2. At time 3, it is there's no displacement, and then 4 and then 5. So we can ato na siya makita no on this graph. If you can see, we have our time 1 here, or T1, position 1, 2, 3, 4, and 5. So this motion, the undamped free vibration response, will continue forever because this is not a damped system. Smalan siya no nga payag sa itong idealization sa ito ang simple structure. At first, we consider, wala pa na ito i-consider si damping. Same also with the equation of motion. Ato sa first pag i-consider no nga undamped free vibration, there is no applied force, and then the damping is equal to 0. Eventually, we will arrive at this specific equation of motion. So the structure vibrates in simple harmonic motion. So we call that oscillation or a harmonic motion. So mo to siya no, this is uniform. This cycle is uniform throughout the system or throughout the time. So the amplitude of oscillation depends upon the initial displacement and then the initial velocity. So it will depend really good no because the rho or the amplitude is just equal to the square of u0 plus square of u omega over the natural velocity of the structure. So kaning natural lang ano nga velocity omega, that is the natural velocity of the structure with or without the effect of the force. So the kung ano kato equation nga u of t is equal to u of 0 cosine omega t plus u dot of 0 over omega sine omega t can be rewritten in this form, equation 11. So, giunsa man nato na siya. And then we have this tangent no formula. So, if you notice no, the amplitude is just the square of the initial displacement and the initial velocity. So, sa to pa si rho or the amplitude is like the hypotenuse of a right triangle. So, we have here the square of our initial what do you call this velocity divided by the natural frequency the natural angular velocity and then the initial displacement and we have our rho on the side. If we say if we have our angle here cosine theta is just the adjacent over the hypotenuse, that is u0 over rho, and rho is rho cosine theta. We cross that rho, we'll have u of 0. Now, if we take sine theta, para ma-appeal na to si u dot, we will have the u 0 over omega over rho, and then eventually we will have u dot 0 over omega is just equal to r sine theta. Now, substitute this value to this equation, na din tayo may tabo nga u of t is equal to rho cosine theta cosine omega t plus we have the rho sine theta sine omega t. And then, since common man si kuan si rho or the amplitude pagawas si rho, we will have cosine theta omega theta plus sine theta sine omega theta. So actually this equation looks very familiar. This is cos sin sin. This is just the difference of the cosine. So that is cosine omega t minus theta. So another simplified equation will look like this. So this one here is our amplitude, and then this one is the angle of our tangent sa ato ang cycle. So moving on. So mo to siya, no? So the oscillation does not decay because the structure is undamped. So mo to siya itong gingon. The structure, no, di ba natay graph? The graph remains constant, it does not decay. Pasabot sa decay is si structure nam kahinay yung oscillation until it will stop. Pasabot there is a decay sa ato ang vibration or oscillation. But here, this structure is not undamped, therefore there is no decay. So the period of oscillation T, we have here 2 pi over omega, or simply 1 over f. So our omega, that is again our natural circular or angular frequency. So this natural singular circular frequency or angular frequency, no, this is regardless if there's an applied loading or not, the structure will have this natural frequency. Our f, small letter f, that is our natural frequency or cyclic frequency. That is, yung unit is cycle per second or hertz. And then the period is the natural period, the time the cycle will, a single cycle will complete. So muna siya si natural period. So let's say now I have a circle here. And then muna ito ang starting position. So let's say kani siya kani siya si circle here. If we try to cycle that one, no, ato siya ipa-travel that one here, muna siya ang complete cycle from the starting point back to the point. So this is a one complete cycle. The period is the time needed to complete that cycle. So, for instance, this material here, we have a cycle of 1 second, or we have a cycle of 2 seconds. So, sa ito pa, one is a delay, it will travel on this part, hinay kay 1 second, and then it will complete its cycle in seconds. So, muna siya ang ito ang period, the natural period in seconds. Or, paspas siya nga 0.5 seconds ang iyang period. So, pasabot, it takes only 0.5 seconds to complete a cycle. Si frequency po is pila ka cycle ang nahimo sa usa ka segundo. So, mo lang siya ang concept ni frequency. That is in hertz. So, si frequency is equal to omega over 2 pi. Or that is equal to cycle per second, yung unit or hertz. Si period, the natural period or the natural time traveled or the natural time to complete a cycle, that is just the inverse or opposite of the frequency. That is equal to 2 pi over omega, or yung unit is just simply seconds. So the term natural is used to qualify each of the above quantities to emphasize the fact that these are natural properties of the structure. So this is just a natural property of this structure, regardless if there is a applied force or applied damping mechanism sa structure. So these properties are independent of the initial condition. So mo to siya, regardless what is your initial displacement or velocity, the natural properties will be the same for the material. So, mo to siya, no? So, this is the equation of motion. So, to solve the equation of motion, we apply the superposition principle. And then, we try to solve a solution. We try to apply the initial conditions. Now, we have what we call a free vibration response. By free vibration response, pasabot, the applied dynamic force is set or equal to 0. And then we have this equation of m u dot double dot t plus c u dot of t plus k u of t is equal to 0. Now we try to consider the undamped conditions sa ito ang structure or na free vibration response. Moto siyang c is equal to 0. By application of the superposition principle, no, since we know that we have our u is equal to g e plus e to the st, so we apply the solution sa to ang general equation of motion. Then eventually we arrive at the auxiliary equation for the equation of motion, like s squared plus c over m s plus k over m is equal to 0. And now, atong first consider hinahinay para mas masabtan na to equation of motion is that andam siya ang condition. Just like ato ang first discussion sa idealized structure na sa to ang structure is wala pa nato giplan og damping, so mo na itong gibuhat sa to equation of motion. First, the c is equal to 0, then you will have s squared plus k over m is equal to 0. So natay new notation we have applied, that is just equal to the square root of k over m. So mo to siya nga natin siya sa tong equation of motion. So eventually we have another set of formulas, and then mo to siya this one here. So we have an imaginary, so the solution is we have a complex root system, and then to remove that one, we applied certain principles. So we have our initial conditions here applied, and the second initial condition applied, then we already our arbitrary constants G1 and C, G2. And then, since naman tayo, if we try to eliminate this exponential nga part, no? Through this concept, we have what we call the Euler's equation. So, dali na lang kayo siya. By applying the Euler's equation, no, we arrive in this cosine omega t plus I sine omega t. So, the Euler's equation actually is derived from this Taylor series of e to the x expand around x is equal to 0. And then, this Taylor series expand around x is equal to 0. We call that the Maclaurin series. And we know that the behavior of this e to the x, kung ato expand siya sa Taylor series, is similar siya sa Taylor series, the cosine omega t, and then the sine omega t gyapon. So that's why we have arrived at this Euler equation. Now we apply these Euler equations sa ato ang general equation na solve last time katong sa u of t. Then we were able to solve to get this equation of motion or the displacement as a function of time as something like this. So since that is a free vibration response, muna yung graph, we try to consider na dayon na we have our amplitude raw. So that is just a equation as the square root of the square of the initial displacement plus the square of the initial divided by the structure's natural circular frequency. So by manipulation no, of our u of t, so ato ang na-relate si u of t with the natural, with the amplitude of the structure and its natural frequency omega. So and then eventually we arrive at this one, this formula. So mo lang ginasyon no, ang basic concept ato is don't forget the equation of motion, mass times acceleration times the response velocity plus ku of t equal to 0, and then we apply the actual equation, the structure, and then we apply those concepts sa tuang cyclic or sa tuang harmonic oscillations. Okay, because we know that when we graph the displacement versus time of this structure, we will arrive with these harmonic oscillations shown. Okay, so if you have any question, you can just PM me for this one. So this is the derivation of the equation of motion for a undamped free vibration response of a single degree of freedom sa ato ang structural or sa atong one-story building.